Welcome to Spark Solvers. Charge up your skill, power up your knowledge. Kirchhoff voltage law, KVL, subject basic electrical engineering. Statement: the algebraic sum of the product of the current and resistance of each conductor in any closed path of network or circuit plus the algebraic sum of the voltages in that path is equal to 0. So in mathematical form, we can write sigma IR plus sigma V is equal to 0. Now, IR is nothing but voltage, or we can say that voltage drop. So overall voltage is equal to 0. So in another word, or in another sentence, we can write that the algebraic sum of the voltages, voltage rise and voltage drops in closed path of network or circuit is equal to 0. Now we know that summation never be 0. So here we have to consider the sign consideration for voltages and voltage drop. Then when it become plus or minus, कि कब वो plus हो रहा है और कब वो minus हमें consider करना है, वो हमें देखना है. So let's start. Determination of sign for EMF. So if loop direction or current flowing from positive terminal to negative terminal, अगर वो plus से minus, which means higher potential to lower potential, अगर इस ओर जा रहा है, then we'll consider voltage as negative. It is known as voltage fall. So we'll consider it as negative. But if current direction or loop direction goes from negative terminal to positive terminal, which means lower terminal to higher terminal or lower potential to higher potential, then we'll consider it as voltage rise, which means positive. So कब voltage minus लेना है और कब voltage plus लेना है. अगर वो positive से negative जा रहा है, then it is negative, और अगर वो negative से positive जा रहा है, then it is positive. Now determination of sign for voltage drop, which means IR. If current flowing from positive terminal to negative terminal, अगर वो resistor में plus से minus की ओर जा रहा है, which means it is similar to higher potential to lower potential voltage. So it is voltage drop, or else current direction and loop direction both are same, then we'll consider it as negative. And the reverse case, if current flowing from negative terminal to positive terminal, which means it is like voltage rise. So, or current direction and loop direction both are opposite to each other, and we'll consider it as positive. Now let's consider one circuit on which we apply the KVL. So there is one circuit giving, there are 3 resistors which are connected in series. Over here voltage is V volt and current flowing in clockwise direction. So we apply KVL on loop or mesh A, B, C, D, A. We'll start from point A. So first we go from A to B, then B to C, then C to D, and then D to A. So here first current flowing from here like this. So first product comes, that is IR1. Now current flowing from positive terminal to negative terminal, and we know that current flowing from positive terminal to negative terminal, we already defined that it is taken as negative. So first minus IR1, then again current flowing from here, again it is flowing positive to negative terminal, so minus IR2. Then here again it flowing from positive terminal to negative terminal, so it is minus IR3, but for voltage it is negative to positive, which means it is voltage rise, so voltage considered as positive is equal to 0. Now when we simplify the equation, so negative goes in RHS become positive, so V is equal to IR1 plus IR2 plus IR3. Now if we see the equation, then this IR1 plus IR2 plus IR3, these 3 are voltage drops whereas this V is voltage rise. So we can say that sigma V is equal to sigma IR, which means voltage drop is equal to voltage rise. So in another word, we can say that sum of voltage drop around in any closed path is equal to the sum of voltage rises in that closed path. So if KVL is asked, the question is state and explain KVL, and you have to write up to this. This question can be asked in 4 marks, 3 marks or 4 marks. Thank you. Thank you. Subscribe for more updates, and you can send your example or query on sparksolvers.community@gmail.com, and for more notifications, press the bell icon. Thank you. Thank you so much.